Hi there. So in this video, we're now going to start moving into the pocketing aspect of this particular program, where we're going to be clearing out some of the deeper elements in this, as well as boring out all of the initial holes around the sides. So we'll go back into the machining environment, and we're going to add a new setup stage, which we are going to call clearance for now. So. Right, and for the first part of this, I would like to be able to use a pocket to bore out all of these negative spaces here, just to get us to a good starting point. Now, obviously, one of these has got some very, very tight edges on it, which is a bit of a problem, so we're going to have to use a smaller tool for that. So I'm going to stagger the way that this is set up so that the very small parts are done in the process next to the small holes, and the larger parts are done initially. So we're going to add a 2D pocketing operation. We are going to change the tool now, so we're going to be using, say, a 16mm tool. Which again will be 60mm long, and we'll apply the changes and create a new tool, and we're going to pick the first parts that we want to pocket out. So that is going to be, and a bit of a trick when you're dealing with through holes like this is if you have stuff, especially with curved profiles like this, is if you select the bottom edge, it's a lot easier to be able to get an accurate selection of the hole. So we turn off machine visibility so we don't have to deal with the table anymore, and we select each of these holes from beneath. So add pockets and add pockets, and again. And again, and I think a 16mm tool will fit this one. Just double check that. And we also want to add a bottom level, which is going to be this base surface here. So select the surface and add bottom level, and you can see those ghostly green marks that were coming up before are now in line with the bottom of the actual hole. That basically controls how far down the machine's going to try and run these pockets, and obviously we wish to limit that to the thickness of the actual material. So we can also select the top surface, which is this. So that's the top height used for this. If we now go back to defining the 6th axis point, so that doesn't throw any problems at us, and we generate the operation, we've got a partial operation at best, but again, this is something the axis map will help us resolve, because we have the exact same issue that we're going to be seeing throughout. Excellent. So that's given us a very rough starting point for this, and obviously this is too small to accommodate a 16mm tool, because it's 15mm, because of course it is. We can either adjust for that now by making this tool smaller, or we can come back to this when we do this bore as well, which is what we're probably going to do. So we're also going to set the radial stock allowances to 1mm again, because we're going to be contouring throughout each of these holes to give them the absolute cleanest finish we can. Turn off that and generate again. And as you can see now, we now have nice and clean setups with nice transitions between them. Which should simulate very, very cleanly. The next pocketing operation we're going to set up, we are going to do these smaller bores. So if we set this up for pocketing again, and this time we are going to use if we go with the 6mm tool, with, again, a surprising amount of stick out of 60mm. That should give us all of the all of the tight clearances we need access to get to in all of these. So we are going to grab our actual holes that we're going to be working to. Now we can't do the bottom layer trick with this one because obviously there's a feature here which, for the sake of this model, we will be, well, for the sake of this particular tutorial, we'll be ignoring that because we're using a 3-axis setup for this. This is purely an example. So if we grab the pocket there and we grab this one here. Now, again, the method that I just showed you working from the base is for being able to accommodate any kind of rolled edges like you've got here. For things with a totally sharp, clean edge, it doesn't matter if you're coming in from the top or the bottom. It has the same effect in the long run anyway. Now, the only issue with grouping both of these holes together is if we set the top surface to be the top of the panel casing here, this particular one is going to be cutting a bit of air first. It's not the end of the world, it's just a little bit of a time waste, which we can probably set this up as its own program, its own sub-program first. So if we were to delete this, and we set this as the top level and this as the bottom level, it means that we should get a very, very quick program knocked out for that. Incorrect values of safe plane or machining levels. Okay, so delete that. That's the bottom level. This is the top level. Let's try that again. Okay. So somehow, presumably by a misclick on my part, the base surface had been defined in this, which confuses matters when you're setting a top level and bottom level. So yes, make sure that you've definitely not got that. So for the sake of these simple pockets, we're only going to be using the top level, the bottom level, and the actual contour chain for these. So that's fine. Click on that, build map. Graph, update the toolpath, that's all good. We'll just make sure that we've got our allowances there. And we'll rerun that. And that's fine. So we've still got the checking for plunges thing defined, which is a bit of a problem. But that's now coming up clean. So we'll define the last pocketing operations the same with all of these. We'll do that now. So I'm going to duplicate the settings for this because 90% of what we've got here is accurate. We just need to change what it's targeting. So I'm going to delete these and I'm going to select this chain. So add pocket, and then we're going to go around and we're going to grab each of these holes as well. And we're going to define these pockets to grab too. We're then going to set this as the top level, and we're going to set this as the bottom level. And we should get a fairly clean toolpath set up to start with. We'll just double check the axis map. I don't see any problems with this, but better to be safe than sorry. Especially given how much longer the toolpath is compared to the previous one. So there we go, that's a nice clean axis map. We're going to update the toolpath and that should behave itself just fine. So that's all of our pocketing clearancing done. So I am going to now run the simulation. We can afford to run it from this same starting point now. It's not a problem since nothing has fundamentally changed. So I'll click on run from here. And I can see where I've already made one mistake in this. I'm hoping that you've caught it as well. Because I defined the radial and axial clearances at 1 millimeter, it does mean that we have got 1 millimeter left at the bottom of each of these pockets, which is something that we want to eliminate. So we're going to go back to the machining now, and for each of these we're going to set the axial stock to 0. And again, that was an oversight, but a useful one to catch this early on. So we're going to go back and we're going to regenerate all of these toolpaths, and they should come up exactly the same as they were before because they're still using all of the same axial mapping information. Now we can reset the workpiece, go back to current operation. Now with solid workpieces like this, it does take a little bit longer to calculate, but it is significantly more accurate, as we will be capitalizing on later on. So if we now run, it's taking a moment to think about it. There we go. And we can see now that it's cut through. Not quite sure why it's left such a thin skin there, but that should be fine. Okay. So yeah, that's that good to go. So the next operations we're going to be looking at are going to be dealing with all of these flat surface areas, and also dealing with the rolled in curved surfaces as well. So we'll be covering that in the next video. I shall see you then.